Susie.
Rob.
It's a day, I've lost track of how many days, day 4?
I mean, it could be any day. I don't know. Yeah, I think it's Saturday.
It is, it is Saturday. I want to be at home in bed. I've seen a lot of talks about dinosaurs, a lot of talks about fish, and I need a rest. How about you?
Yeah, I mean, much the same. I don't know what it is about travelling, but I sleep like rubbish in a hotel room.
Yeah.
Oh my God, I haven't slept longer than about 5:30 in days.
Right, let's tea and then come back to this. Okay, Susie, we caught up 2 days ago.
Yeah.
You were busy doing all sorts of Roma Prize things. Who won, important question, who won the cricket sixes?
Well, not me, Rob.
Not you, you lost. You said you were going to be so angry if you lost to Richard.
I know. I not only did I lose to Richard, I also lost to Kirsty, Davide Foffa and Harry.
So you have been obliterated.
I was obliterated. I held the lead very briefly.
Yeah.
And then Harriet just absolutely stormed in with a small orange child's plastic bat and just smashed the hell out of the ball.
So has your pride taken a bit of a hit then?
I don't know that I care that much.
You did before.
Well, if there was a chance I was going to win, then definitely.
Yeah, all right, okay, I'll allow it. So last night was also an authors event thing that you were hosting. So we had, who was there? Thomas Halliday of Other Lands fame, Henry G, Elsa Pancharoli, who I've been trying to track down actually, and you. No, you weren't hosting, were you?
No.
Podcasting hero. Tom Holland of Historian fame, not Spider-Man fame, he was there, wasn't he? So how'd it go?
Yeah, so he was chairing.
Yeah.
And, you know, it's interesting to have somebody who's not a paleontologist asking questions, which was, you know, I think, coming at it from more of a literary point of view. So, you know, there were parts, I'll be honest, there were parts that lost me. When they were talking about opera and plays, I was like, yeah, no, I've got nothing. Thomas Halliday, incredibly well-read, knows lots of things.
He's a very sophisticated man.
He is.
He likes his croquet and his opera.
Yeah. And so it was very, very interesting and, thoroughly enjoyed it. There was a storm last night. Was it Claudia?
Something like
that. Anyway, enormous storm. We had 210 people booked for the event, and we only managed to get about 50 people, which was a bit sad, really, because it was such a good event. But there was absolute chaos.
So, what did we learn about being a paleontological author?
I think that they talked a lot about the wonder and how to, as a working paleontologist, how to convey or maintain that sense of wonder to the general public.
Oh, that's interesting, because some of the talks I've been at yesterday could have done with a bit of that advice. No, some of them were great, but I think some of them needed a bit of that wonder sugar sprinkled on top of them.
The wonder sugar, you know, I'm not a fan of the overly slick TED Talk style talks, but it's interesting, isn't it? Because when you are reviewing the abstracts, which I do, obviously for the Roma, but also, you know, when programme committee, there's an enormous number of people who there have been over 900 abstracts submitted to this meeting.
900.
So you need an enormous number of people who are actually going to review those abstracts. Every abstract's reviewed by 3 people and ranked by 3 people. Yes. And it is inexplicable to me how we still end up with talks that are, and here's some fossils I found on my summer holidays, in 6 views. And actually they're not very complete, and I'm not really sure what they are. And it just...
Well, let's be clear, those are in the minority.
They are in the minority.
There's been absolutely... Let's talk about the more positive things that have been interesting. What are the things that you have excited you? Yeah,
so I sat through the Triassic Symposium yesterday, which unprecedentedly for SVP, I think, they had so many submissions for. It actually ran as a full day symposium. Wow. I mean, the Triassic is a really interesting time period.
Well, we've done... For fossil files, I think we have done Triassic more than anything else, seemingly.
Probably. I mean, it lasted a really long time, right, the Triassic, so you've got a lot of coverage to get through there. But, you know, it's the beginning and the end of the Triassic are mass extinction events, 2 of the big 5 mass extinctions, right? So we have... interesting patterns that you can tell if you're looking at recovery from mass extinctions or what happens before mass extinctions and things like that. But also, it's this time period when you have, like, loads of really, really, really wacky terrestrial animals evolving.
Yes, the wacky... I was talking at lunch yesterday with some Ken Aljelzik of Chicago. He was telling me about some interesting stuff. I'm not sure if I'm allowed to share that, but there were some wacky terrestrial Triassic things that I was like, oh, that's piqued my interest. Anyway, I wasn't at the Triassic session. I went to the ancient biomolecules session, which was kind of fun because there was lots of new high-powered techniques. So this is like, the new thing used to be CT and synchrotron data, but I think this ancient biomolecules thing, if you can use these high-powered techniques to get a handle on the actual chemistry and link that to the biology, and therefore the evolution, there's potentially a whole new avenue of things coming up. But it's a bit, what's kind of exciting is it's kind of new and fresh. We don't actually know what direction it's going to go in yet, but
no, and the techniques are really being developed, aren't they? Right now.
Yeah, indeed, they're hot off the press.
They're hot off the press, and they're controversial. Like some people are like, oh no, what X is doing is actually they're totally misinterpreting Y. And I was having some of those chats with some of our some of my colleagues here. I've been hearing pros and cons about some of the methods.
The opportunity of being is I can go and talk to the people directly and ask them, you know, what about, have you thought about this? What about that? And that's been fun. Yeah. Although, of course, the difficulty is it quickly devolves into arguments that are quite arcane and technical for me. I could talk about chemistry, I could talk about biology, but when you start talking about phase physics and the devices, I go,
You've got nothing.
This is why we have to have interdisciplinary research, right? Well, this is why you talk to the people from those.
Well, paleo's super interdisciplinary, isn't it? Like we have people, I mean, even just our backgrounds, you know, we come from entirely different backgrounds in terms of our undergrad degrees, but people can come in from all different disciplines.
Well, as evidence when I was talking to Luke Mascot yesterday, who was doing his robots, you know, he's doing jet
He's an engineer,
on the side.
Isn't he?
His paleo is a side project when he's doing his jets.
Yeah. So what are you looking forward to today, though, then?
Well, I've got a bit of a conflict because there's some really good fossil mammal things happening, but those fossil mammal things are happening at the same time as some interesting taphonomy things, so I have to make some decisions, and then there's some tetrapods this afternoon. How about you?
Yeah, same. There's a few talks that I've gone, oh, that one's really good. Oh, that sounds interesting. Oh, they're at the same time.
Yeah, I can't do both at the same time.
Yeah, but also, of course, it's dinner tonight. And we all enjoy eating food, getting drunk, and listening to talks that go on for. Well, we've got to run the annual book, of course, on how long the president's talk will go on for.
Well, I hope it doesn't go on too long because I have to get on the train tonight to go home for the Laser Quest party tomorrow. I have 15 8-year-olds tomorrow that I haven't constructed the party bags yet.
Oh, Rob. It's going to be a hard day.
Don't.
Well, I'm leading the field trip. I'm leading a field trip that leads at 8:15 tomorrow morning or something.
Oh, no.
So that is also going to be a hard day.
Well, I'll think of you when I'm at the Laser Quest, and you'll think of me when you're on that train in Storm, Claudia, Julia, wherever it was. Right, see ya.
Bye.
So, it's the last day of SVP, and everyone's a bit tired, but I've managed to track down Dr. Stephanie Drumheller at the University of Tennessee. So, nice to meet you, Stephanie. We've not met before, have we? But you just gave a talk in the previous session that went down very well just before lunch. Lots of decaying crocodiles.
I didn't pick the time slot.
But just before that, I guess I should introduce you. Stephanie is at the University of Tennessee and does all sorts of interesting research on crocodiles and chase fossils and ecology and dinosaurs as well. But your most recent talk was all about, well, why don't you tell us what it was all about?
All right. So there's quite a bit of research out there that looks at the different stages of decomposition, how things decompose. But a huge amount of that research has been done on mammals because it's being done by forensic anthropologists or archaeologists. And so we love mammals, they're great, they're a wonderful model, but we've been sort of taking all of that data and uncritically applying it to everybody else.
Yes.
And since I mostly work on reptiles, that's a bit of a problem because there are anatomical differences. There are all kinds of differences. Mm-hmm. So a lot of my current research is trying to replicate some of those foundational studies in mammal decomposition, but doing it with reptiles and seeing what is the same, what's different, and how does that affect how these things might end up in the fossil record.
Brilliant. So some of the context you make clear was because you were approaching from the idea of these dinosaur mummies, these very famous, nice preserved skin impressions and things like that. And if you want to understand their preservation, then you need some actual understanding of how bodies rot and change during time, which is something I'm very sympathetic to.
Yes.
But of course, this is so. You did all these experiments rotting them. Is this at the famous body farm, or is it a different place?
No. So the forensic anthropology facility at UT is only for people, actually.
Only for people, right?
But I'm maybe just 5 minutes up the road, and I work on a piece of property managed by our agricultural campus. It's a very similar idea, though, in terms of putting these things out and just making observations as they decompose. And it is definitely nearby, but.
Lovely.
And I'm collaborating with people who also work there.
So the body farm, just for people that don't know, is the one where we actually it's for doing forensic experiments with humans, letting people donate their corpses. And
Tennessee's was actually the first one in the world.
Yeah, it's famous. So. I include it in my undergraduate lectures, but I have to warn them. I'm about to show you a picture of a decaying body. But so that reminds me a little bit of sometimes when I'm doing decay experiments. You know, not everybody is knocking down your door to be recruited, but those that are into it are into it. When you ask your students, can you go and sample this decaying corpse of a crocodile, are they enthusiastic, or how do you find the willing volunteers?
Usually what happens is I'll have a bunch of people who want to do research with me, and I'll say, okay, I have multiple different projects. This is one of them. And if they say they're interested in that one, I at this point have a little pitch where it's like, okay, look, it is gross. This is not for everybody.
Yeah.
There's no shame if you need to back out.
Yeah.
But of the ones who initially are interested, I would say over half of them end up sticking it out and hanging out and staying with me. But it is pretty gross. We would like to tease one of my colleagues because it was probably a tactical error on our part, but we took him out to go see the tegus on like day 3 or 4, which was pretty bad.
That was not the peak badness.
Oh yeah, that was not the best time to take someone out there who usually works on Paleozoic echinoderms. So,
can you describe just the smells?
Oh, it's rough. I'm not even sure how to explain it.
Yeah.
But you do sort of weirdly get used to it.
Yeah.
So it doesn't bother us as much as initially, but you can smell them from a ways away.
Yeah.
Especially,
that's why you need to be out in the rural agricultural land. You can't be doing this in the lab. All your colleagues at the department will be pretty annoyed.
No, they would not. There's a reason they give me access to a fume hood, and it has nothing to do with chemical experiments.
So, what did you find out?
A lot of stuff, actually.
Yeah.
So there are some of these studies that have been done with mammals that play out pretty well when we're looking at reptiles. So stuff like what insects come to the remains after they die, and how do things weather when the bones have been exposed for long periods of time. But there's other aspects that don't look similar at all. And one of them is that skin tends to stick around a lot longer in the reptile samples than what we see in mammals. And that has a lot of strange downstream effects in terms of how the skeleton falls apart and how protected the skeleton is from things like weathering. How it disarticulates. So we're having a lot of fun with it, but it's definitely a situation where a lot of our findings in retrospect make a lot of sense because they're explaining things we see in the fossil record. I was joking in the talk about how there's this long-standing complaint that we never find sauropod skulls, and I think part of it is we're seeing why.
Yes, well, that was an interesting point. You also made the point about the infamous death pose. If I was to do the death pose now as on an audio format, it would not work. But with the head kicked back,
head thrown back, tail thrown back, yeah.
And you gave the good idea that actually that might be the skin dragging back. Because I have a terrible attention span problem, I've just noticed a party barge go past. That's Birmingham Saturday. We're having a party barge time. Oh, it looks like a hen party. It's a hen party. You wouldn't call it a hen party. What would you call it?
I guess like bachelorette party.
Bachelorette party.
So.
Yeah. They're having fun. Sorry for the distracting. Okay. I don't often see a canal barge of a hen party going by. So all these interesting results, but you're also looking at the bacteria and the fungi and things like that, which is things that I'm particularly interested in. But I'm going to ask you about that separately because
partnering up with Jen de Bruin and her student Hannah Noel over in microbiology in the Ag Campus at the university. So they've been coming out and looking at soil chemistry. They've been looking at plant chemistry, so the plants that are growing around the bodies and what are they taking up. They've been taking swabs off of the animals themselves. We actually have all of those samples for the crocodilians as well, but those are still waiting to be processed. But the results we're getting back from the tegus, at least, again, a lot of it lines up with what you would expect from the mammal literature. Yeah. But then we have some odd things that pop up, like fungal signals that seem to line up with groups that break down keratin, which makes sense if you're covered in scales.
There's a lot of keratin in these things.
Yeah, a lot for them to eat. So,
do you think you have any? I mean, there's been debates about whether or not keratin. So keratin, just for those not in the know, is your bones and scales and hair. Not bones. Your teeth and nails and. Goodness gracious, I have to edit this out. Leave again.
Nails, hair, like rhino horn, all that.
All of
stuff.
that things. That's what all your keratin is. But sometimes people get quite in-depth arguments about whether keratin can or cannot fossilize. But I'm guessing you might be able to demonstrate that with some actual data.
It's something that we're interested in looking at, and certainly with my, I guess I have to call her former graduate student because she graduated. Hannah Maddox is going on to look at sort of the post-burial geochemical changes, and I think that's part of what she's going to be diving into is how do the skin and other dermal tissues get stabilized, because again, we really suspect that a lot more skin is surviving to burial than we might expect. As paleontologists, a lot of times we only think about the hard tissues, we think about the bones. But if these things are getting buried with skin, we have a sneaking suspicion there's probably a lot more of these skin-type fossils out there and mummies out there that we might have been missing. And at a bare minimum, that these things were getting buried with a lot of skin, even if it did not then survive the fossilization process.
Lovely. So I guess that's the final question, I guess, is what are the actual implications for the dinosaur or mummies and the mummification process more generally?
So for the modern stuff, the implication that we're getting is that this reptile style of skin can persist for a very long time on the landscape. So we've got tegus that have been decomposing for well over 2 years now that still have skin associated with them.
So can you just, I mean, tegu, can you explain briefly what a tegu is for those that are not familiar?
Oh, so Argentinian black and white tegus are the groups that we're working with on that side of things. They are, we'll say, indiscriminate carnivores that are popular in the pet trade. So you might have seen them in a pet store.
Yeah, lovely. Okay, so sorry, you were just telling us about the tegu data.
No, so we have skin that's still around more than 2 years after we set these things out. And that has implications in terms of, there's been the sort of general wisdom is to get a dinosaur mummy, you have to bury it very, very quickly. And you get all of these hypothetical situations, like it was literally buried in a flood and that's how it died. But what we're seeing, we see some more indicators that these things were actually laying out on the landscape for quite some time. We find things like insect traces on bone. It looks like there's no internal organs left behind. It's just this empty skin on the skeleton, which is much more characteristic of late stage, dry stage decomposition. Absolutely. So it shifts the game a little bit in our understanding of how these fossils form in the first place.
So your results are going to be extremely relevant for that paper that came out very recently about dinosaur mummies, one presumes.
No, we were very interested in seeing those results because, again, with the geochemical stuff that Clint has been doing, sort of expanding that data set, we're seeing different signals. And the mummy that we're working on certainly looks like there's some three-dimensional, potentially, preservation of the skin, whereas the ones that Evan Saida and Paul Serino and that team were working on, they're seeing a very different style of preservation. And we're seeing some similarities in terms of the mummies from the Hell Creek are getting a different chemical signature than the mummies from where he was working. So I thought it was really, really interesting, and I think that our data is going to end up jiving with his with mummies that preserve in that way.
Nice.
But we very strongly suspect there are actually multiple pathways to become a mummy that we've been trying to kind of shoehorn together to come up with one explanation for everybody. I'm not sure we're there. I
well,
think
you
we're
set
looking
yourself a
at
challenge there because, of course, the taphonomic circumstances can change a lot from place to place.
Oh, yeah.
Yeah, so, but you won't be able to get anywhere without the data that you're generating is going to go a long way to helping with all of that. Indeed, on that very point, at the end of your talk, I came over to just grab you for 2 seconds. You had a queue of people waiting to talk to you. So it's obviously gone down very well. Lots of popular
It seems to. And a lot of people were, have you thought about working with this group? Have you thought about working in this environment? And I'm like, yes, all the things. All of the things in all of the environments. Please go forth and rot birds and like just whatever else you want to do. It's something that on the mammal side of things, that kind of work has been done. People have been replicating results in different environments, different groups of organisms, and if we can start to get other groups of vertebrates to that same level of sampling, there's a lot of amazing stuff that's being done on the mammalian side of this that we could be doing too.
The mammals are leagues ahead of the other ones.
We just have to do the legwork to get there.
But there is good reasons for that, as you pointed out at all, right? If you forensic science, mammals are the model you want to do. If you want to reconstruct a grisly crime scene, they're more often involving humans than crocodiles. So
absolutely,
you might want some mammal data.
But at the same time, I mean, I've had people reach out and want to talk to me about things like wildlife forensics. So if you have animal poaching or smuggling cases, you're trying to figure out when this thing died, and all you have is the mammalian data set to compare it to. So there's broader implications beyond just paleontology, and I love that about it too. It's interesting to a variety of fields.
Thank you very much. Thanks, Stephanie. It was a pleasure to meet you. Thanks for joining the Fossil Files.
Thanks for talking to me.
Right, hello. It's day 3 of SVP, and I am here with Bolor Minjin of the New York Museum, American Museum of Natural History, and I have to get the phrase right, the Mongolian Institute, she's showing me the piece of paper, Institute for the Study of Mongolian Dinosaurs. Thank you. So, Bolor, you've done a lot of work working with communities in Mongolia on protecting dinosaurs and educating people, and that was what your talk was all about this morning. So it sounds like you've been very busy.
Oh, yeah. I mean, always been, because there's so much of projects we're doing right now, all at the same time. Yeah. It's a good time because, we pass certain phase and then start new one. At the moment, we're going into new phases of new projects.
Absolutely. So you were talking this morning about your project to go and educate the local communities, especially children in Mongolia. So obviously one of the things you mentioned is the high challenge of the low population density. So, but you've got this bus where you were touring around and meeting those, but it sounds like you've been a great success. So how does the bus work? What's on the bus?
I mean, this bus has actually been in New York City all over. And maybe like 8 years. And so, like I said on my presentation, Bloomberg Foundation stopped funding the Natural History Museum in New York. And so we got this bus. It's like 37 foot long, like 250 square feet space, has 3 different sections, talk about dinosaur extinction and bird and dinosaur, relationship and all of that. And so, so the challenging thing was, I did mention on my presentation that all texts are English. And
I see. So you had to adapt it.
Yeah. And so this is before AI, right? So, so I had all kinds of things thinking like.
So was that your job to translate it all?
No, I mean translating will take a lot of work. So instead we use technology like AR, or augmented reality.
So AI is able to translate it into Mongolian. It's Cyrillic, isn't it?
Yeah. So it's AR. I mean, it's translated physically, and then using the augmented reality that can change it English to Mongolian.
So how? I mean, are you? So it's a technology out in the middle of the steppe. It's amazing. So how did the children respond? Were they? I guess they must have been enjoyed by this. Were they overwhelmed by this? How many of them were aware about Mongolia's deep paleontological heritage before you got there? Or was it only after you got there they understood?
Oh, it's totally after I got there. Yeah, because, I mean, I've been all over. I interact with people, and even like during like middle of the conversation, I would ask about, do you know that Mongolia has dinosaurs? And people would say, no. You know, even I'm speaking with my friends, and I say, do you know about the dinosaurs? And so, very limited knowledge in terms of like. Maybe they heard like, oh yeah, maybe some dinosaurs found, and it's very common. You know, some people wear that dinosaur egg nest been found by Andrus's expedition, M&H stuff, but they cannot name any single Mongolian dinosaurs.
So that reminds me, when we went out to the far west of Mongolia a long time ago with your father, we went out to look for Paleozoic fish. The people we met were very, very friendly, friendly, but they were also curious as to what we were doing, and we would stop and explain. I mean, we went out so far west that we were dealing with the people that didn't speak Mongolian, they were speaking Kazakh. So that was a challenge, so we had to translate through the Kazakh, the Russian, the French. Anyway, they were curious, and when we explained we were looking for fish, they said, well, why are you looking for fish? There's gold in the hills, why don't you go and get the gold? Because there's illegal mining going on. But that was another question I wanted to ask you about, because you mentioned in your talk this morning the education project, which it sounds like it's absolutely fantastic work, and you've got a lot of results. But you're also protecting Mongolia's paleontological heritage, because there's a lot of illegal activities going on over there. So your new museum is going to hopefully provide a home for a lot of these things. How is the museum building going?
Currently we have a land at the Flaming Cliffs. So now I have a American architect who's interested in the project, and her concept and design got award from international organization, and so that really gives good boost for the museum project. So we now currently on fundraising phase, and also we speaking with Mongolian government to get the seed money to support the project.
But this is not in Ulaanbaatar, right? This is far out.
Right at the Flaming Cliffs.
Okay.
Yeah.
So Ulaanbaatar has a museum already, but this one's going to be closer to the actual site. So tell us about the Flaming Cliffs.
Well, Flaming Cliffs, it's late Cretaceous site. First been found by Central Asiatic expedition that led by Roy Chapman Andrews. So through that expedition, our first dinosaurs being discovered, like Velociraptor, Protoceratops, and Pinacosaurus.
All the famous ones.
All the famous ones, and then including the egg nest, right? So since then, many foreign expeditions been at the site, and what happened is all of those fossils left the country for research, study. So because of that, like I said on my presentation, local community never learned about this discovery. So, and even they don't have the access to the specimen because it's all in New York, Russia, Poland, and all over the world. So another aspect of the museum is it will be community run, and so all people who work in will be from Fleming Cliffs area. So now we already have a director for the museum. She lives in Bolor town, that is next to the Fleming Cliffs, and she got actually like museum management training in Los Angeles County Natural History Museum.
Great. So it sounds like you're at quite a mature stage already.
Well, I think before the building, we need to train the people.
Yes.
And so there's the two students that I showed on my slide show who's doing research with me. And one of them, she actually grew up next to Fleming Cliffs, and she lives there. And so she's now a third-year undergraduate student. And then she also been through our program since high school. So I've been with her.
Oh, so she's been here for a long. That's nice. So she's grown up with and around the whole thing from the beginning.
Yeah, with our program, and so I've been with her since high school, and so now working on a research with her. So after she finishes undergraduate, she's going to PhD program. So I'm looking for some PhD program with fellowship to support her to study outside of Mongolia. Then when she finishes, she goes back and she will work in this new museum. So she will be the paleontologist.
Great. So this museum is going to play a really important role for supporting the community, supporting the heritage. But it's also, I guess, an aspiration might be to try and not stop, but halt the illegal export of fossils. I mean, how does one stop illegal export of fossils? I guess that's a difficult challenge.
Yeah, I mean, it's difficult, but I think it's possible. And I think we making some, progress on it. And, 2012, that, famous case of Tarbosaurus patara was on auction. So since then, 13 years I've been working on repatriating those stolen dinosaurs from U.S. So all these fossils been sent back now in Natural History Museum in Mongolia. Most importantly, working with the community, especially community living right next to it. And the thing is, we do have parents whose children in our young explorers, young scientist program, been selling fossils.
Oh, I see. Right.
Yeah. So I think.
So, but the children might now be able to educate the parents potentially. Is that one of the?
I think. So what happened is so how students were chosen from the community. We only ask one question about them, if they have interest in science and what really sparks their interest in science. So we just make like an interview, and we don't see their grades, if it's A students, D, C students. It's all based on science interest. And so then we also interview parents.
Oh, right.
Yeah, and also the teacher, school teacher. So to make this program successful for the kid, we need to work with parents, school. It's like all of us to make sure these kids succeed. They're not necessarily become a paleontologist, but they can be interested in science.
Yeah, no, of course. Yeah.
And then they don't really have to go to science anyway.
Well, I think you made the point earlier that it's absolutely right that people could be living and working on the land that they have no idea is internationally significant. Just in the first instance that they're from a country that has a rich heritage in paleontological heritage.
Yeah.
That's so well done. I look forward to hearing more about the project and the bus. Is the bus still on the road?
Bus is actually now in garage.
In the garage, right?
Yeah.
It's big, this thing. I don't know how you shipped it from the US. It is big.
Well, it couldn't fit in the container. Actually, I drove with the driver to New Jersey port from M&H to ship it, but can't fit in the container, so it drives into the ship.
Wow.
And then went to China and loaded on back of a big truck.
Wow. And
then from between China and Mongolian border, loaded on a train. and went to Ulaanbaatar. From Ulaanbaatar, we drove down to Flaming Cliffs.
So I need to tell the people listening that Bolor had this amazing video of this very massive American bus like driving across the empty Mongolian steppe. It's quite the image with the sun setting. It's a good video. Well, anyway, thanks Bolor for giving us some time to talk to us. Good luck with the projects there and in New York. Thank you.
Oh yes, well thank you so much.
Right, it's the final day of SVP and the talks are finished, the posters are finished.
No, they're still going.
They're still going. Sorry, the posters are still going. I've managed to track down Emily Rayfield. Full disclosure, Emily is my pal and we've been pals for a long time. But she is also a biomechanics ledge, right? Is that fair to say? You look embarrassed at that prospect.
Yeah, I feel really embarrassed about that.
But it's not a secret that you've been doing, well, I wouldn't say invented it, but should we say pioneered?
Pioneered, I think, is an appropriate.
Pioneered the use of finite element analysis, which is an engineering approach to reconstruct mechanics and function of extinct organisms.
Yeah, right? I'm not clever enough or good enough maths to have actually invented anything like that.
But you pioneered, right? Let me. Right, all the talks are finished at SVP and everyone's tired, but I've managed to track down Professor Emily Rayfield. Professor Emily Rayfield and long-time buddy and fan of the fossil files.
I think I've listened to 2 episodes.
Well, that makes you an official fan.
Right, thanks.
To ask you about what you've been... Yes.
Thanks.
So you've been at a special session today that you convened, right? Or co-convened.
Indeed. Yes.
All about skulls, interdisciplinary approaches to skulls, is that right? And evolution.
Yep.
Now, and the reason that is because you kind of pioneered some of the approaches to using engineering, finite element analysis to reconstruct the function of extinct organisms, and 20-something years later, if you don't mind my saying, it's still going. That must be a nice feeling.
Yeah, I guess so.
Yeah.
I guess I did pioneer it, really. It's just embarrassing when you kind of think about it in that way. Yeah. You know, it's because you end up. It's often like with the way science works, you end up coming at something at the right time in the right place, and the right tools are actually coming together. So it was the fact that people had used that method before to look at various other bits and pieces of different organisms. So like there was a study on the beak of a shoebill and some other studies about echinoids and things like that. So it wasn't entirely unknown in zoology and VP as well too. There was some preliminary studies that had looked at some simple models of synapsid skulls as well too. But I think it was what really helped was the advent of CT scanning as well too, because finally that allowed you to generate a geometric data set that gave you the internal and the external geometry of a specimen that you could then create a more accurate 3D shape, which was the precursor to then doing the engineering analysis on.
Absolutely. So this started in dinosaurs because, everyone loves dinosaurs. And would you describe yourself as a dinosaur researcher? No, you were just
so I started doing the work on dinosaurs. Interestingly, I wanted to work on early tetrapods, really.
Tonight. But you have ended up working on early tetrapods.
So I have ended up working on early tetrapods.
So you found
and
your way back.
And I think that's one of the beauties of doing something which is, you have a method, you kind of build on that, which is a bit like the symposium we were doing today, where you bring in lots of different aspects of this toolkit to actually, where the core aspect is to understand the function and the evolution of these structures, skulls, limbs, whatever.
So what's the next big challenge, do you think? So you've been doing this for a while. I won't say how long. I
think you just said.
I've already done. So you've been doing it for a while. What do you think the next big challenge is then? Where's it going to go next? Or am I giving away too many secrets because you're going to write this for your next grant application?
Yeah, exactly. Yeah.
Well, don't worry, no one's listening. It's just you and me.
Yeah, well, no one's listening to
this. No
one's
listening, that's fine.
Okay. Yeah, just me and getting my badge
so what's the next step then?
I think there are two things, and one of the things that still we really need to work out is like how much do we need to understand lots of the missing pieces of the puzzle that go into the model? How much do we need to understand material properties? How much do we need to understand the muscle forces that go in? These are all things that we don't know in extinct animals. We don't know, the elasticity of a dinosaur bone because it's been mineralized. We don't know what the muscles look like, how big they were, how long their fibers were because they're gone, apart from very exceptional circumstances. And so we need to do more of the work that helps us understand how these input parameters are really important to model results.
Yeah.
And that's not an insignificant task. It's really difficult to
no. But you've
collect all
gone a
that
long way
data.
to do a lot of validation.
We've done a bit of the stuff, yeah. I mean, it's tricky. But I think alongside that, is this idea that you've got to formulate your questions in such a way that they can be addressed by the data that you have.
So for people that are not familiar with FEA then, why don't you tell us some of the sort of problems that you've been able to solve with it?
Well, it's a method that is used is used in engineering analysis. It's the kind of, if you did a degree in engineering, you would be taught how to use this method. It's commonplace. It's derived from a mathematical basis, and essentially it's a way to understand how a structure responds to external loading. Given its material properties, so how stiff or elastic it is in response, and then the stress and strain and deformation, at least if you do this kind of static model, which is mostly what we do. So you can get an idea of how a structure stresses and strains. That's kind of interesting in itself, but actually what that tells you for an extinct animal is the kind of behavioural loads that skeletal structure can withstand.
So we're talking about like how it runs.
Yeah, exactly.
So you can use. So you've demonstrated how a dinosaur skull would and would not function, right? Or at least you predict to make it.
Yeah, exactly. I think we would estimate it or predict it.
Or a pterosaur wing, or I don't know, fish swimming. Have you done any fish swimming?
No.
No, you've lost track. Okay, so maybe not a fish swimming because the bones wouldn't be small. Would it?
But I mean, so one of the problems we're looking at the moment is the evolution of the mammalian jaw. And that's a really cool problem that is actually rooted in how the jawbones function and how they could continue to function if indeed they did, while transitioning into two of the three bones that make up the mammalian middle ear. So, and that is a classic problem, which has been suggested to be a functional situation. And so we can then use these methods to say, okay, well, how does the loading on the joint change as these animals evolve? And what does that mean for the fact that what we can see in the fossil record is that the bones at the back of the jaw get super tiny and then two of them go into the middle ear.
Which is indeed why, will you be able to solve the problem for my mum, who's really annoyed that when I chew my food, my jaw clacks, and she told me to go and get that fixed because she's fed up with it. And the dentist said, that's just it. Right? And it is indeed just how our jaws have evolved, right? You're not going to solve that problem.
But FE is used has got a huge application in things like TMJ, so your temporal mandibular joint, which is your jaw joint that's messed up. It's used commonly in that kind of application. And actually some of the earlier studies that I remember reading when I was doing my PhD was some of the really advanced work was on kind of human TMJ, and it was using it from a medical perspective. Whether I can help your mother or not. I'm not sure.
Well, I think you should find something else to get annoyed about, so I don't know that would help. Right, we probably need to go and have some time at the post session and have some drinks and then enjoy a long set of speeches at the banquet. Right, thank you, Emily. I'll see you later. Bye.
Thanks, Rob.
The Fossil Files was presented by Robert Sansom and Susanna Maidment. You can find more information, including links to the original papers that were discussed, at fossils.libsyn.com, and you can contact us at fossilfiles.pod@gmail.com.